everyone, so today we're going to start a new chapter. So we're going to start going over properties of quadrilaterals. So your quadrilaterals are going to be closed figures formed by four segments intersecting at their endpoints. So in this example here, A and B, for A, these would be considered quadrilaterals because all the figures are closed and they're intersecting at their midpoints. B, this one is not closed, so wouldn't be considered quadrilateral. Here there's an intersection somewhere in between, and this part here is not considered a segment. Alright, so going over the definition of a parallelogram is going to be a quadrilateral, so it's going to have four sides, and then your opposite sides are going to be parallel. So for example 1, we're just listing all this information. So for the first one, we have the parallelogram at the right has four vertices. They are angle N, angle M, angle P, and angle O. Or sorry, not O, Q. If I'm going too fast, just pause it and then write down the information. For B, we have, it would be named, so we named it by the vertices. So one way we can name this is M, N, P, Q. Don't circle the information, but that's one way you can name it. Oops. Another way you can name it is you can start at any point, go clockwise or counterclockwise. So I could have said N, M, Q, P as well. So just pick one point, then go either clockwise or counterclockwise. Alright, so next we're naming the opposite sides of our parallelogram. Alright, so here our opposite sides would be MN and PQ, since those are across from one another. And the other pair would be NP and MQ, so these two here. Next we have our opposite angles. So remember, your opposite angles are going to be across from one another. So angle M and angle P would be considered opposite angles, and so would angle N and angle Q. And then lastly for U, we have the consecutive angles of our quadrilateral MNPQ are. So for consecutive, that just means next to each other. So we're just naming the angles that are next to each other. So angle N is next to angle P. Angle P is next to angle Q. Angle Q is next to angle M. And then lastly, angle M is next to angle N. Alright, so on this page, we're going to start writing properties. So properties, think about these as rules that apply to any parallelogram. So for any parallelogram, we can assume that the opposite sides are going to be congruent. That just means that they're going to be the same length, and they're also parallel, which means that the opposite sides are never going to meet. For your opposite angles, they're going to be congruent, so the same thing. So if angle M is 50, angle P would be 50. And consecutive angles, so the angles that are next to each other, like M and N, those are going to be supplementary. So remember, supplementary means that they add up to 180. Alright, next you have to know what a diagonal is. So a diagonal is a segment joining opposite vertices in a polygon. So here we're given two examples already filled in. So if you're having a hard time getting the information, then you can look at that and then figure out what the vertices name, opposite vertices and diagonal would be. So for this first one, this rectangle, the vertices would be considered DOGS. So make sure you put commas in between. The name, again, just pick one letter and then either go clockwise or counterclockwise. So we can name this DOGS, or we could have said DSGO, doesn't matter. Opposite vertices are going to be D and G, and then O and S. And then our diagonals, so again, your diagonals are going to be connecting your opposite vertices. So DG would be considered one diagonal, and then OS would be considered another diagonal. Then I'm going to skip this last one, but same idea as this one here. You're just going to name them based off the information. Alright, so the last property that we're going to go over is diagonals bisect each other. So what that means is whenever we draw the diagonals in a parallelogram, this piece and this piece would be the same length, and then this piece and this piece are going to be the same length. But this one and this one here are not the same length, so just be careful with that. Alright, so for example 3, we have complete each statement regarding the parallelogram below. So first we're going to name this one. So again, doesn't matter where you start. Just make sure to either go clockwise or counterclockwise. So I can say this is DC, BA. Then we have AB. The symbol here means parallel. Make sure you remember that. So AB is parallel to DC. We have DA is congruent to its opposite side. So CB. Angle CDA is going to be congruent to its opposite angle, which is right here. So we would name that angle ABC. And then lastly we have DE. Would be congruent. So DE is this piece here. So it would be congruent to this piece here. So EB. Alright, so now we're going to start getting into some algebraic problems. So for example 4, it says if ABCD is a parallelogram, so I would say draw your figure. So this is the figure I drew. Again, doesn't matter where you put A as long as you go either clockwise or counterclockwise. So here we know that angle A is X, angle D is 2x minus 3, and we're asked to find what the value of X is going to be. So you have to think about what is the relationship between A and D. So we know A and D are angles and they're next to each other, so it would be considered consecutive angles, which we know that consecutive angles are supplementary. So that means that we would have to take angle A, add it with angle D, and they would add up to 180. So now we have to go through and solve for X. So combine our like terms, we get 3x minus 3 is equal to 180. Then add 3 to both sides. We end up with 3x is equal to 183. And then divide by 3 to get the value of X. So we would end up getting that X is equal to 61. If this problem was asking us to find the measure of angle A, then we would just plug in 61 back into our problem and then do the same thing with D. Alright, example 5, we have X, Y, Z, W. So I just drew my figure. So we know it's a parallelogram, and it says with diagonals XZ and YW. And it's saying that they're intersecting. So remember, intersect just means where they touch. So they're touching at point A. And we're told that XA is 3M. AZ or ZA is 5M minus 4. And lastly, that YW is 10M, and we're asked to find M. So this problem, they try to trick you. But again, go back to your properties. So if we look, this problem is dealing with diagonals. So you want to think about what property deals with diagonals. So there's only one. The one property says that diagonals bisect each other. So that means that YA would be congruent to, or sorry, not YA. XA would be congruent to ZA. So we would just set an equation with those two segments. So 3m is equal to 5m minus 4. So here if we were to solve for m, we can subtract 5m from both sides, giving us negative 2m is equal to negative 4. Divide by negative 2, and we get that m is equal to a positive 2. Alright, for the following, we're just applying the properties. So the first one has to deal with angles, so we have to know that opposite angles are always the same. So since 80 is across from x, x would be 80 degrees. And then since 80 and z are consecutive angles, that means that they would add up to 180. So we would have to do 180 minus 80 to figure out what z would be. So that would end up giving us 100. Whoops, sorry, I put it in the wrong spot.